Hello. So welcome to the new video. So in this video, we'll discuss about the vertical circular motion. That means if we will provide some initial speed, initial velocity to the object, then at different position of its motion, what will be the energy at that position, we'll calculate, and what will be the speed. Okay. Vertical circular motion means it will move or revolve in a vertical axis. Okay. In and in horizontal it is parallel to the ground, it will move like this. In vertical motion it will move like this. Okay. So suppose I have this charger, suppose it's connected, so this is the mass. Now if I'll give some initial velocity like this, so it will go up. Okay. And it will move like this, so it will move like this. So this is your vertical motion of the object. Now if I'll provide some velocity here, some initial velocity, you can see when it is going up, gradually the velocity is becoming less. But if I'll provide sufficient initial velocity here, then only uh, it will be on the circular motion, or it will be on the track. Okay. But if I'll not provide the sufficient initial velocity, then it will go, and it gradually the velocity means will become less, and this tension also will not be, there will be no tension, so it will slacken. Okay. It will fall down like this, it will not be in a track of the circular motion. So here mathematically we'll try to calculate what will be the velocity at different positions and what are the energies. So let us see what is the energy at different positions. So let's say the object is in a vertical circular motion. This is not in a horizontal. This is in a vertical circular motion, and let's say this is from center to a point on the circumference. Okay. And the mass is here, the mass is hanging here, the mass, let's say m is here. Okay. So now this mass is provided with an initial velocity, let's say v0, and let's say this position is a, and we will find out the velocity at position b here and another position at position c. So at three positions we will calculate the velocity, what will be the velocity and what will be the energy. One thing we have discussed in the previous videos, or that mechanical energy at all positions are equal. That means the total mechanical energy at position A, the total energy at B, the total energy at C, all are equal. So we will use that concept, and we will calculate the velocities. What will be the VB? Our target will be VB. What is VB and what is VC? Right. Initial velocity is given to you. Initial velocity, you know the initial velocity when the object is projected, means given initial velocity. So V0 is known to us, let's say. So if a mass is hanging here, what will be the force on this mass? It's hanging, so tension force will be there. Tension force will be there upward because it's hanging, and gravity is pulling it, so mg downward, of course, due to weight of the object. Now you projected with a velocity, you strike the object, okay, with a velocity v0. Then what will be the velocity at different position? So first we'll calculate what is the energy. What is the kinetic energy of this one at position A? So energy at A, half mv0 square, isn't it? This is your kinetic energy or not? So this is your kinetic energy, that is half mv0 square. Is there any potential energy? No, it's almost at the nearly at the position of the ground, just a little bit above the ground. It's nearly close to ground, this position. So we are considering this position is close to ground. Okay, this is close to ground, close to ground. So at position A, the potential energy is, there is no potential energy. Mgh is, height is, no height is there, so mgh is 0 approximately. So only kinetic. So what is the total energy at object of the object at position A? The total energy of the object at position A is half mv square. And what if there is no vertical motion here at position A? That means T and mg, they are balancing each other. They are equal. T is equal to mg. Okay, they are balancing each other, else the object will go upward else. So they are balancing. T is equal to mg. So this is the energy at your position A. Now you can write that this T is there, and then what will happen? The object will go up in a circular track. That means T will constantly pull it. T will be, so who is supplying this centripetal force? Because an object, if it is in a circular track, it will have the centripetal force. So who is providing the centripetal force? The centripetal force is provided by T minus mg. T minus mg. So initially T is equal to mg when this object was hanging just. Now you provided a velocity. Now the object is in a circular track. Object will revolve in a circular track. When it is in a circular track, it will have some centripetal. At that time, it will have some centripetal acceleration. So, and centripetal force will act on it. So that centripetal force will keep the object on the track, or it will pull it towards the center. So it will pull it towards the center. That means T must be greater than mg. T should be greater than mg, else it should go, or it should go away from the track if mg will be greater than T. So T will be greater than mg, and T minus mg, this difference, this tension and the, because you should pull. Okay, if I am hanging here, so I should pull it more than it is outward force, that is mg. Okay, or component of a different position, and it will have its different different mg will be there. Okay, component of mg will be there. So we can write that from Newton's second law, T minus, when the object will start moving, not initial position, no motion. When V0 was not there, T is equal to mg. Okay, so T minus mg is equal to mv square by r. R is this radius. Okay, mv0 square by r. This is your this is from Newton's second law. Okay, now this is T at A, tension at A, because tension will also vary. At position B, the tension will not be same. At position C, the tension will be minimum. Okay, it will be in opposite direction. So tension is not same in all the directions. So tension at A minus mg equal to half mv0 square. Once you applied one force or one velocity here, then your difference in force must be equal to this centripetal force, so that the object will be on a circular track. Okay, v0 square by r is the centripetal force. So this is from Newton's second law. Okay, now what is let's go to the C position. Let's go to the C position. Let's see what will happen. Let's see what will happen. At C, you can see that the tension on the string is almost zero, because it will slacken. There will be no, it will not stretch forward. Okay, no need to pull it. So the tension is almost zero at position C. At position C, Tc is approximately zero, almost zero. Okay. So if Tc is approximately zero, so who is providing the circular motion? Who is providing the necessary circular, providing the centripetal force for the necessary circular motion? Okay. So here mg will be downward. Though T is zero, but mg is keeping this one in the circular track. So here we can write that mg minus Tc is zero. Okay, at position C. At C we can write at position C. This is at position A. Okay, at position C, mg minus Tc. Here Tc and mg are in same direction. Tc is zero. So mg, I'm directly writing mg is equal to mvc square. What is the speed? Vc square by r. Okay, mvc square upon r. And what is the energy here? Here you see the energy is, it is already at a certain height, so it will have a potential energy. It will have a potential energy. What will be the potential energy? Height is what? Now r, this is also r. R plus r, 2r is the height of the, means the at position C, the mass m is at a height 2r from the ground. So we'll write the energy at C is mg into 2r, or 2mgr. 2mgr, okay, plus half mvc square. This is 2mgr. 2r is 2r, mgh, right? Potential energy is mgh. So h is 2r here at position C. So we can write mg into 2r, or we have written here 2mgr. So this is the energy at C, but we know that the total energy, that is the sum of here potential and kinetic, the total mechanical energy or total energy at different position must be same. Energy is a conserved quantity. That's why we can write EA is equal to EC, and from there we'll get some conclusion. Okay. So we can write that. Right, mg is equal to this one and EC is equal to this one. So we can write EC is equal to, we'll simplify, we'll put here, okay, that mg will write this one. So 2 mg is mv square upon r, mvc square upon r into r plus half mvc square. So r get cancelled, right? So mvc square, half mvc square, what will happen? 2 mvc square, 2x plus half x is 5 by 2x. I'll jump to 4, so 5. So this is your 5 m vc square, 5 by 2, 5 by 2 m vc square. Okay, this is a 5 by 2 m vc square. Or you can also write in another way. This is one expression in one way of expressing, or you can write that mvc square upon r is mg, or mvc square is mgr. So in terms of mgr also you can write that 5 by 2 mgr. 5 by 2 mgr also you can write. Okay, 5 by 2 mgr. What is that? That is your EC, energy at C, position C. Energy at position A is this one. Why we are doing that? Because we need the velocity at different positions. Okay, we need the energy at different positions. So what should be this velocity v0? What should be our initial velocity v0, so that it will go at least up to this one? Okay, without slackening. Just it will be tension 0, but it can easily it can go up to position C. Below that velocity, it will not even go this much. It will go here and it will fall down. Okay, like this case. If we'll put some velocity, it's not going up. But if I'll put sufficient velocity, then it will go up and it will revolve. Okay, so that's happened. So if so the velocities, so what should be the initial velocity if I want to calculate? What should be the initial velocity? The initial velocity will be, just we'll compare these two equations, because we already have told you EA must be equal to EC. So energy EA is equal to EC. So we can write that half m v0 square is equal to 5 by 2 mgr. 2 cancel, cancelled. So okay, so your v0 square is this one. So v0 is 5 mgr root over 5 mgr root over. Okay, 5 m cancel now, 5 gr root over 5 gr root over under root 5 gr. So what should be your initial velocity, so that it will go at least up to C? So your initial velocity should be G, that means approximately 10 if we'll say, so 50 into R. So R, if your R is suppose 1 meter, so 50 or half meter means 50 centimeter, let's say. So, or half meter. So half meter means if 50 by 5 into 10, 50 by 2. So 25. Okay, 25 root over is 5. So 5 meter per second. So if your length of this radius is, means the length of this wire is half meter, whatever the mass may be, you have to, if we'll throw it with 5 meter per second, okay, then it will go up to this one, it's up to C position. Okay, so it is independent of the mass. Initial velocity is independent. It does not matter what velocity, what mass you have. That much you have to push it in such a way that its initial velocity will be 5 gr on the road, so that whatever, so it depends upon R. Okay, so more is the R, more should be the velocity to keep it on the track. Okay, for a vertical motion. Now we'll calculate what is the VB? So VB and VC will calculate. Okay, so we calculate V0 we calculated. Now we'll calculate VC. Okay, so VC will calculate that we know you see VC will calculate, we already have mg is equal to m VC square upon R. So from here only you can calculate directly VC. So from this is, suppose this is 1, this is 2, this is third equation. So from 3, okay, so from 3 okay, from 3 we can write that mg is equal to mvc square upon r, mm cancelled, so we can write vc is equal to gr vc is equal to gr under root. So what is the velocity at position C? Position C, this is your position C, this is B, and this is A. So what is the velocity at position C? gr under root. Okay, it depends upon what is your r again. If r is more, then vc will be, means it of course depends upon the initial velocity, and also it depends upon the your radius. Okay, so if r is given, okay, if r is given, then you can calculate what is the your velocity at position C. You can calculate. Now we'll calculate VB. So how will you calculate VB? Again, we'll use the same concept of energy. Okay, so at B position, what is the total energy? At B, EB is equal to half mVB square. This is your kinetic energy. What is the potential energy? You can guess. Potential energy at position B, it's exactly half of this your diameter, or you can say, so this will be R only. What is the height? Okay, because you know potential energy is a means it does not depend upon the path. Okay, which path, it depends only on initial and final position. So it only depends upon the height. It doesn't matter that you have taken from here to here, or here to here, or straight you have moved here to here. In all, here or here or here, in all the positions, the potential energy is constant. Okay, the potential energy is constant. So that's why the potential energy will be mg, this is r. Okay, so half mv square plus mg r, and this is equal to, you can write that this is equal to the energy at A position. So you can write that EA is equal to also EB. Okay, so you can write that half mVB square is plus mgr is equal to half mv0 square. half m v0 square. Now you can cut m and m cancelled out. Okay, and you can write down that we have calculated VB is what? We'll calculate VB. We have calculated V0 as V0 as what is V0 we have calculated. So V0 we have calculated. Here we had calculated, just I erase. So V0 we had calculated. V0 we have calculated as 5GL. 5G R under root. Okay. So if I put it here in place of V0 square, so this is half 5G R. This is equal to half VB square. This is equal to GR, or if I take GR to the right side, then it will be VB square half is equal to 5/2 GR minus GR. This is 2 5GR minus 2GR. So you can write this is 3/2 GR. 3/2 GR is what? Half VB square. So VB square, so half of cancelled. So VB is what? VB square is 3GR, or VB is root over under root 3GR. So now you can see we have calculated VB, we have calculated VB, we have calculated VC, and we have calculated V0. What should be the initial velocity? What should be the velocity at position C, the top position, and what is the velocity VB, which is at a height, your radius times radius, height of the radius. If the object is at that height also, then what will be the velocity? So VB, VC, and V0. In all the three positions, we have calculated the energy and velocity. Okay. Then in this question, one more thing is asked, that calculate ratio of the kinetic energy at position B to position C. Okay, that we can do. Ratio of kinetic energy calculate also the ratio of kinetic energy. Calculate the ratio of, so KE B divided by KE kinetic energy at C. So what is kinetic energy? Half m VB square by half m VC square. So half m cancelled out. VB square upon VC square. What is VB? VB square we got 3GR. VC square I have erased, but VC square we have calculated as GR. We have calculated it. VC square as GR we had calculated. Okay, so we'll put this is GR. Cancel. This is 3:1. So the ratio of kinetic energy at position B and position C is 3:1. Okay, so that means the kinetic energy at position B and is 3 times approximately than the kinetic energy at C. That means the kinetic energy is reducing gradually. Okay, kinetic energy is reducing gradually, and also you can compare with V0. Okay, with V0. So if V0 is 5 GR, so if we take 5 GR by this one, so it is 5:1. That means the kinetic energy at C at A is 5 times of the kinetic energy at C. That means kinetic energy is gradually reducing and become 1/5 of the kinetic energy at position A. Okay, so gradually it's decreasing. So this question is this question is an example given in NCERT book, and if you are following NCERT book, it's good. If you are not following the NCERT book, it's also not problem. Just I have explained the question easily for the vertical motion. Okay, so if you find any difficulties, then you can comment. I can discuss in one more class. Okay, so this is example 6.7. This is your example 6.7. This is example 6.7 of your NCERT book. Okay, and for others, you can just, as I have explained. So the question is, we have a mass M was hanging here, and we have provided a initial velocity V0 so that it will make a vertical motion, circular motion. So at different positions, what is your velocity and what is the ratio of the kinetic energies at different positions, and also what is the total energy at different positions we have discussed. Okay, so for this video discussion, we'll stop here. In the next video, I'll discuss more about we'll discuss about some more problems. Thank you.